Now, a biconditional statement occurs when both a conditional statement and its converse are true. So remember back to what we talked about earlier. I'm going to scroll up for a second. The converse happens when you switch the location of the hypothesis and conclusion. And sometimes you get a truth value of false. But if it's a true biconditional, then both the conditional statement and the converse will be true. So let's find some situations for that. Also, a biconditional can be created in the form hypothesis. So whatever your hypothesis is, if and only if, and then the conclusion. Now you will see us shorten this, and you're welcome to do it as well. You will see us write the phrase IFF in between the hypothesis and conclusion, and that stands for if and only if. So that's a little shortcut for you. If and only if, IFF. So we're going to take a look at some examples and see if we can create some biconditionals. My first one says, if you are a freshman in high school, then you are in the 9th grade. As a conditional statement, is that true? If you're a freshman in high school, are you considered to be in the 9th grade? Yeah, that's true. Okay, so next we're going to write the converse. The converse, remember, we switched the location of the hypothesis and conclusion. I am going to first start by identifying my hypothesis and my conclusion to make sure I am ready. So remember, the hypothesis and conclusion do not include the words if and then. Those stay where they are. So I'm going to switch the hypothesis and conclusion and get if you are in 9th grade, comma, then you are a freshman in high school. So is that also true or false? If you are in 9th grade, then you are also a freshman in high school. That is also true. So since both of these are true, I can write this as a true biconditional. So the words if and then go away, and I write the hypothesis, you are a freshman, in high school. If and only if, so comma, if and only if, that came out really weird, if and only if, comma, you are in 9th grade. So that is our true biconditional. You are a freshman in high school. If and only if you are in 9th grade. Let's look at one more example. This one states, if two angles are complements of each other, remember complements mean sum of two angles equals 90, then their measures have a sum of 90, which is exactly what we just said. Is that a true statement? Absolutely. That is a true conditional statement. If two angles are considered complements of each other, then they have to have a sum of 90 degrees. Now the converse, we're going to switch the places. if, and with these, you're not going to just say if their measures have a sum. That doesn't make sense. You're going to include the two angles. So if two angles have measures with a sum, comma, oh wait, sum of 90 degrees, comma, then they are complements of each other. So you have to, on some of these, especially the biconditionals, be mindful of the wording and make sure that it makes sense when you read it out loud. If I had said, if they have measures with a sum of 90 degrees, then two angles are complements of each other, that does not grammatically make sense. So think about what you're talking about and where you might need to keep certain words. Now, looking at the truth value, this is also true. So I can also write this as a true biconditional. Now, remember, not every example I'm going to give you can be written as a biconditional. So please be mindful of that. So our biconditional statement will say two angles are complements of each other if and only if, and I'm going to use that IFF on this one, if and only if, and I'll move it so you can see it, IFF, their measures have a sum of 90 degrees.